Backfeeding an electrical panel by double-ending an extension cord can be extremely dangerous and should never be attempted. When backfeeding an electrical panel, you are essentially using it as a load selection center. This means that you can connect multiple appliances or devices to the panel, which can easily overload the system. Overloading can cause wires to overheat, leading to electrical fires or equipment damage. Backfeeding can also create a neutral ground fault. Normally, the neutral wire in an electrical panel is connected to the ground wire. However, when backfeeding, this connection is broken. This can cause voltage to fluctuate on the neutral wire, creating a shock hazard and potentially damaging appliances. When you backfeed your panel, the ground fault protection circuitry is bypassed. This means that if a device develops a ground fault, no current will flow to trip the breaker, leaving you exposed to electric shock. Electrical fires are a major risk with backfeeding. Overloading or neutral ground faults can cause wires or equipment to overheat, leading to a fire. The use of extension cords and improper wiring during backfeeding can further increase the fire risk. Backfeeding is a violation of electrical codes. It is illegal and can void your insurance coverage if an accident occurs. Attempting to backfeed your electrical panel can have serious consequences, including electrical fires, shock hazards, equipment damage, loss of insurance coverage, and legal liability. If you need to power essential appliances or devices during a power outage, there are safer and more effective alternatives to backfeeding, such as using a portable generator with a transfer switch, installing an automatic standby generator, or using a power inverter. Never double-end an extension cord to backfeed your electrical panel. It is an extremely dangerous practice that can lead to fires, shock hazards, and other serious consequences. Always choose safe and code-compliant methods for powering your home during power outages. To elaborate on the dangers, consider the typical wiring in a home. The electrical panel serves as the central distribution point for electricity. Circuit breakers protect each circuit from overloads and short circuits. A properly wired system includes grounding to provide a safe path for fault currents, minimizing the risk of electric shock. Backfeeding bypasses these safety features. Extension cords are not designed to handle the high current loads of an entire electrical panel. They are typically rated for 15 amps or less, whereas a main breaker in a home electrical panel can be 100 amps or more. Connecting an extension cord to a generator and plugging the other end into an outlet effectively turns the outlet into an entry point for power, sending electricity back into the panel. The first problem is overload. The extension cord can easily overheat and melt, creating a fire hazard. Secondly, the circuit breakers in the panel are designed to protect circuits from overcurrent flowing from the utility grid, not from a generator feeding back into the system. They may not trip in the event of an overload or short circuit. Thirdly, the neutral ground connection is compromised. In a normal electrical system, the neutral wire is connected to ground at the service entrance. This provides a reference point for voltage and helps to ensure that fault currents flow back to the source, tripping circuit breakers. When backfeeding, this connection may be lost, creating a floating neutral. A floating neutral can cause erratic voltage fluctuations, damaging sensitive electronic equipment. Furthermore, it increases the risk of electric shock, as the ground wire may no longer provide a safe path for fault currents. The lack of ground fault protection is another significant concern. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electric shock by detecting small leakage currents to ground. When backfeeding, the GFCI protection is bypassed, leaving occupants vulnerable to potentially lethal shocks. Electrical codes, such as the National Electrical Code, or NEC, strictly prohibit backfeeding. The NEC sets standards for safe electrical installations. Backfeeding violates several sections of the code, including those related to overcurrent protection, grounding, and wiring methods. Violating the NEC can result in fines, penalties, and denial of insurance claims in the event of an accident. It's crucial to understand that backfeeding not only endangers the person performing the task, but also anyone else who may come into contact with the electrical system, including family members, neighbors, and utility workers. Utility workers who are working on downed power lines expect the lines to be de-energized. If a homeowner is backfeeding the panel, it can energize the power lines, creating a life-threatening situation for the utility workers. There are several safe and code-compliant alternatives to backfeeding. One option is to use a portable generator with a transfer switch. A transfer switch is a device that allows you to safely connect a generator to your electrical panel. It isolates the generator from the utility grid, preventing backfeeding. The transfer switch typically includes a main disconnect that shuts off power from the utility and a generator breaker that connects the generator to selected circuits in the home. Another option is to install an automatic standby generator. An automatic standby generator is permanently installed and connected to the home's electrical system. It automatically starts up when the power goes out and switches over to generator power. Once the utility power is restored, the generator automatically shuts down and switches back to utility power. Standby generators are more expensive than portable generators, but they offer the convenience of automatic operation and can power the entire home. A third option is to use a power inverter. A power inverter converts direct current, or DC, electricity from batteries to alternating current, or AC, electricity that can be used to power appliances. Inverters are typically used in conjunction with batteries and a charging source, such as solar panels or a generator. They can provide a limited amount of power for essential appliances during a power outage. When choosing a generator or inverter, it's important to select a unit that is properly sized for the intended load. The generator or inverter should have enough capacity to power all of the appliances and devices that you want to run simultaneously. It's also important to follow all of the manufacturer's instructions and safety precautions when operating a generator or inverter. Remember, electricity can be dangerous. If you're not comfortable working with electricity, it's best to hire a qualified electrician to install a transfer switch or standby generator. Attempting to backfeed an electrical panel is never worth the risk. It's a dangerous and illegal practice that can have serious consequences. Always choose safe and code-compliant methods for powering your home during a power outage. To delve deeper into the technical aspects, let's examine the specific hazards in more detail. The concept of electrical overload is central to understanding the risks. Every electrical circuit is designed to carry a certain amount of current. The current carrying capacity is determined by the size of the wires and the rating of the circuit breaker. When you exceed the current carrying capacity of a circuit, the wires overheat. The heat can melt the insulation on the wires, creating a short circuit. A short circuit can cause a fire. Extension cords are particularly vulnerable to overload. They are typically made with smaller gauge wires than the wiring in the walls of your home. This means that they have a lower current carrying capacity. If you plug too many appliances into an extension cord, it can easily overheat. The neutral ground fault is another serious hazard. In a properly wired electrical system, the neutral wire is connected to ground at the service entrance. This connection provides a reference point for voltage and helps to ensure that fault currents flow back to the source, tripping circuit breakers. When backfeeding, this connection may be lost. The loss of the neutral ground connection can cause a floating neutral. A floating neutral can cause erratic voltage fluctuations, damaging sensitive electronic equipment. It can also increase the risk of electric shock. The ground fault protection is another important safety feature that is bypassed when backfeeding. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electric shock by detecting small leakage currents to ground. If a GFCI detects a leakage current, it will trip the circuit breaker, cutting off the power. When backfeeding, the GFCI protection is bypassed, leaving occupants vulnerable to potentially lethal shocks. The National Electrical Code, or NEC, is a comprehensive set of standards for safe electrical installations. The NEC covers everything from wiring methods to overcurrent protection to grounding. Backfeeding violates several sections of the NEC. For example, NEC Section 110.3 B requires that electrical equipment be installed and used in accordance with the manufacturer's instructions. Extension cords are not designed to be used for backfeeding. NEC Section 250.24 requires that the neutral conductor be grounded at the service entrance. Backfeeding can compromise this grounding connection. NEC Section 700, 701 and 702 covers emergency, legally required, and optional standby systems. These sections specify the requirements for generators and transfer switches. Backfeeding does not meet these requirements. Violating the NEC can have serious consequences. It can result in fines, penalties, and denial of insurance claims in the event of an accident. It's also important to consider the legal liability associated with backfeeding. If someone is injured or property is damaged as a result of backfeeding, the person who performed the backfeeding could be held liable. In addition to the technical and legal considerations, it's important to be aware of the safety precautions that should be taken when using a generator. Always operate the generator in a well-ventilated area. Generators produce carbon monoxide, a colorless, odorless gas that can be deadly. Never operate a generator indoors or in an enclosed space. Keep the generator dry. Do not operate a generator in the rain or snow. Connect the generator to the electrical system using a transfer switch. Never plug the generator directly into an outlet. Use heavy-duty extension cords that are rated for the load. Inspect the extension cords for damage before each use. Do not overload the generator. Follow the manufacturer's instructions for operating the generator. In summary, backfeeding an electrical panel is a dangerous and illegal practice that should never be attempted. It can cause electrical overload, neutral ground faults, and fire hazards. It can also void your insurance coverage and expose you to legal liability. There are several safe and code-compliant alternatives to backfeeding, such as using a portable generator with a transfer switch, installing an automatic standby generator, or using a power inverter. Always choose safe and code-compliant methods for powering your home during a power outage. The dangers associated with backfeeding extend beyond the immediate risks of fire and electric shock. Consider the potential for long-term damage to appliances and electronic equipment. The voltage fluctuations caused by a floating neutral can wreak havoc on sensitive electronics, shortening their lifespan and causing them to malfunction. Surge protectors may not be effective in protecting against these types of voltage fluctuations. Furthermore, the improper grounding associated with backfeeding can create electromagnetic interference, or EMI, which can disrupt the operation of electronic devices. EMI can cause computers to crash, audio equipment to produce static, and video equipment to display distorted images. The cumulative effect of these problems can be significant, leading to costly repairs and replacements. The environmental impact of backfeeding is also worth considering. When a generator is overloaded, it burns fuel inefficiently, producing more emissions. These emissions can contribute to air pollution and climate change. Additionally, the improper disposal of used motor oil and other fluids from generators can contaminate soil and water. From a public safety perspective, backfeeding poses a threat to utility workers. Linemen and other utility personnel work on power lines assuming that they are de-energized. If a homeowner is backfeeding their panel, it can energize the power lines, creating a life-threatening situation for the utility workers. This is why it is so important to use a transfer switch to isolate the generator from the utility grid. A transfer switch ensures that the generator power cannot flow back into the grid, protecting utility workers from harm. The cost of installing a transfer switch or standby generator is relatively small compared to the potential costs associated with backfeeding. The cost of a fire, an electric shock, or damage to appliances can easily exceed the cost of a safe and code-compliant generator installation. Moreover, the peace of mind that comes with knowing that your home is powered safely during a power outage is priceless. When selecting a transfer switch, it is important to choose one that is properly rated for the size of your generator and the electrical load in your home. The transfer switch should be installed by a qualified electrician. When selecting a standby generator, it is important to consider the power requirements of your home. The generator should be sized to handle the essential loads that you want to power during a power outage, such as lights, refrigerators, and medical equipment. A qualified electrician can help you determine the appropriate size generator for your needs. It is also important to have the generator installed and maintained by a qualified technician. Regular maintenance, such as oil changes and tune-ups, will ensure that the generator operates reliably when you need it most. In conclusion, backfeeding an electrical panel is a dangerous and irresponsible practice that should be avoided at all costs. It is a violation of electrical codes, it can create a variety of safety hazards, and it can expose you to legal liability. There are several safe and code-compliant alternatives to backfeeding, such as using a portable generator with a transfer switch, installing an automatic standby generator, or using a power inverter. Always choose safety over convenience when it comes to electrical power. The NEC addresses generator installations extensively. For example, NEC Article 445 covers generators, including their installation and wiring requirements. NEC Article 700 covers emergency systems, which includes generators used to supply power during emergencies. NEC Article 701 covers legally required standby systems, which includes generators required by law to supply power to certain loads. NEC Article 702 covers optional standby systems, which includes generators used to supply power to optional loads during power outages. These articles provide detailed guidance on how to safely install and operate generators. They cover topics such as overcurrent protection, grounding, wiring methods, and transfer equipment. Compliance with these articles is essential for ensuring the safety of generator installations. Local codes and ordinances may also have specific requirements for generator installations. It is important to check with your local building department to determine the applicable codes and ordinances in your area. These codes and ordinances may address issues such as noise levels, emissions, and setbacks from property lines. They may also require permits and inspections for generator installations. Failure to comply with local codes and ordinances can result in fines and penalties. In addition to the NEC and local codes, there are also industry standards that provide guidance on generator installations. For example, the Electrical Generating Systems Association, or EGSIT, publishes standards for generator performance and installation. These standards cover topics such as generator sizing, testing, and maintenance. They also provide guidance on the selection of appropriate transfer equipment. Following these industry standards can help to ensure that your generator installation is safe and reliable. When working with electricity, it is always important to follow safe work practices. These practices include wearing appropriate personal protective equipment, such as safety glasses and gloves, using insulated tools, and energizing circuits before working on them. It is also important to be aware of the potential hazards associated with electricity, such as electric shock and arc flash. Arc flash is a dangerous electrical explosion that can occur when working on energized equipment. It can cause severe burns and other injuries. To protect against arc flash, it is important to wear arc-rated clothing and use appropriate arc flash protection equipment. If you are not qualified to work on electrical equipment, it is best to hire a qualified electrician. A qualified electrician has the training, experience, and equipment necessary to perform electrical work safely and correctly. Attempting to perform electrical work without the proper qualifications can be dangerous and can result in serious injury or death. In addition to the safety considerations, it is also important to consider the environmental impact of generators. Generators produce emissions that can contribute to air pollution and climate change. To minimize the environmental impact of generators, it is important to choose a generator that is fuel efficient and that meets emissions standards. It is also important to properly maintain the generator to ensure that it operates efficiently. Additionally, it is important to properly dispose of used motor oil and other fluids from generators to prevent contamination of soil and water. By following these best practices, you can help to minimize the environmental impact of generators. In conclusion, backfeeding an electrical panel is a dangerous and irresponsible practice that should be avoided at all costs. There are several safe and code-compliant alternatives to backfeeding, such as using a portable generator with a transfer switch, installing an automatic standby generator, or using a power inverter. Always choose safety over convenience when it comes to electrical power. Remember to consult with a qualified electrician to ensure that your generator installation is safe and code compliant. And always follow safe work practices when working with electricity. This will help to protect yourself, your family, and your property from the dangers of electricity. Never forget that electrical safety is everyone's responsibility. By working together, we can create a safer electrical environment for all. It is also vital to regularly inspect your electrical system for any signs of damage or wear. Look for things like cracked or frayed wires, loose connections, and damaged outlets or switches. If you notice any problems, have them repaired by a qualified electrician as soon as possible. Ignoring electrical problems can lead to serious consequences, such as fires and electric shocks. Another important aspect of electrical safety is to educate yourself and your family about electrical hazards. Teach children about the dangers of electricity and how to avoid them. Make sure that everyone in your household knows how to identify and respond to electrical emergencies. This includes knowing how to shut off the power in case of a fire or electric shock. By taking these precautions, you can help to create a safer home for yourself and your family. Electrical safety is an ongoing process that requires constant vigilance. By staying informed, following safe work practices, and maintaining your electrical system, you can significantly reduce the risk of electrical accidents. And remember, if you are ever unsure about something, it is always best to consult with a qualified electrician. A qualified electrician can provide expert advice and guidance on all aspects of electrical safety. The investment in electrical safety is an investment in your health, your safety, and your peace of mind. Do not take electrical safety lightly. It is a serious matter that deserves your full attention. Backfeeding can lead to energized lines, creating electrocution of line workers, which is a very real concern for not just the homeowner doing the backfeeding. Use of proper equipment is the only method that should be implemented to provide backup power safely. And there is no excuse to ever backfeed a panel under any circumstance.